I've been spending quite a bit of time digging into the Vue 3 source code lately and noticed there aren't many resources to understanding how all this stuff fits together. So in the next few videos I thought I might go over each of the packages and explain how they all work. Today we're going to be starting with the reactivity system, which is pretty neat, and we're going to be building our own very simple little reactivity system from scratch, and it's going to be very similar to the one in Vue 3. I'm going to try as close to possible to stick to the same variable names and conventions that they use in this actual code base. And the goal here is to give you a mental model so you'll be able to go dive into this code base and actually read it and figure out how it all works. So let's go ahead and get started. There will be an article version of this available, which I'll post in the description as well. If you'd like to follow along, I have a very simple project set up. You can see my package.json is here. And I have an empty file called ref, which is where our implementation is going to go. And we have a very simple spec file set up here. So let's go ahead and see what we're going to be building. This is going to be our goal here. We're going to build a very simple reactivity system just using ref, which is just going to work on strings. However, we're going to set it up in such a way we could easily scale it to be working with more complex things like objects and that sort of thing. In this case, we have a foo ref, which is equal to foo, and we have a new variable here, which is going to be undefined. We then have an effect here. You've probably seen ref if you've worked with Vue 3 before, but you probably haven't seen effect. You have seen similar things though, such as watch effect, watch, and computed, which all use effect under the hood. Basically, this effect function is what powers the entire reactivity system, and we're going to see how this one works in just a moment. For now, what we're doing here is creating an effect, and inside of here we're assigning foo to be equal to fooref.value. And this is going to be executed, so foo is now going to be equal to well foo. That's what we say down here. We then go ahead and say fooref.value is equal to bar, and because we have reactivity via ref, what should happen is we execute the effect again, and we're going to update this foo variable to be equal to the new value of fooref.value. In this case, it's going to be bar, and we're going to hopefully get this last assertion to be passing as well. So let's go ahead and start coding something out. The first thing we're going to do is get rid of all these compilation errors. So let's go ahead and run our tests in watch mode just to get a nice quick feedback loop. So let's just go ahead and start that with the watch all flag. It's obviously going to fail because we haven't created ref or effect, so let's go ahead and do that first. First thing I'm going to do is export a new constant here, and this is going to be ref. It's going to take a value which is just going to be a string, and it's going to go ahead and return something. In this case, what we're going to do is return a new ref implementation. I'm calling this ref implementation for a very specific reason. This is exactly what it's called in the Vue 3 code base, and we're following that as closely as possible. And we're going to pass in our value here. Let's go ahead now and create the ref implementation class. Of course, it's going to take a constructor in here, which is going to receive a value. I'm just going to say val, which would be a string. And then what we would do is go ahead and assign it. So I'm going to create a private value in here. It's just going to be called value as well, which is going to be a string. We'll change this one to be, let's just say val. And what I could do here is just say this dot value is going to be equal to value. There's actually a shorthand I'm going to show you right now. Instead of typing all this code out, what we can actually do is go ahead, delete this one, and just say private value in here. And that's going to automatically do the exact same thing. It's going to create a new local variable called value and assign this value to it. So we have a little bit of a shorthand there. Now that we have that, let's go ahead and set up get. We're going to have a new get in here. It's going to return the value. And for now, all we're going to do is say return this dot value. That should be enough to get rid of the ref compilation error. If we head back to our test, we can see ref is now not erroring anymore. However, effect is still going to be erroring. So let's go ahead and implement that one as well. For now, we're just going to export a new const called effect. It's going to take a callback, which is going to be a function. And all we're going to do here is go ahead and execute it. And if we save this one off, we're actually going to see our errors are all gone. We are getting a failure on line 16. If we head back to our spec, we can see that our first assertion is going to pass. This does make sense. We're executing this effect immediately, or this function here, and we're updating foo to be equal to fooref.value, which we know is going to be foo. However, this one is not going to work. We haven't created the setter, and goes without saying, this is going to fail as well. Let's go ahead and implement the setter just to get rid of that last error. So we're going to say set value. It's going to take a val of, let's just say string. And for now, we're just going to go ahead and assign it to this.value is equal to val. If we save that off, head back, we can see our compilation errors are now gone, but we are getting an error on line 18. Of course, it's saying foo is meant to be equal to bar, and this is not the case at all. We are updating the value here. However, we haven't got any sort of reactivity or dependency tracking, so this effect here is not going to be executed again. The goal here of this effect is going to be to re-execute this every time any of the dependencies changes. In this case, fooref is going to be, or fooref.value is going to be a dependency of this effect, and every time this changes, we're going to go ahead and re-execute the effect. In practice, this actually helps to think about it the other way around. We're going to say this effect here is dependent on foo.value. If this ever changes, we need to re-execute this effect and update all of the values inside of here to be equal to the new foo.ref.value. And the way this is going to work is we're going to implement two functions, one called track and one called trigger. Let me show you a diagram just to make this a little bit more clear. So you can see here we have our effect and we're saying foo is equal to foo.ref.value. We have set up that getter over here, we already have this, but we have an additional extra function here called track. So what we're going to do is every time someone accesses the value, we're going to see which effect is currently being executed. In this case, it's going to be this effect over here. And we're going to go ahead and track that. So then we're going to say every time this value is accessed, we're going to call or invoke the effect again. We can also say that this effect is a dependency of this foo.ref.value. And that's the first thing we're going to go ahead and implement. Once we know which effects are dependent on which values, we can figure out how we're going to do the other end of this, which is going to be triggering all the relevant effects every time something changes. So let's start about implementing that. Just to show you where this is located in the code base, if I come into ref, you can see we have something very similar to what we've just coded. Let's just quickly look at our code over here. The first thing we have is that function called ref, which we're exporting, and that is down here. They're calling a function called createRef, which is actually very similar to what we're doing as well. They come in and do some extra checks and then just say return new ref implementation. If we go ahead and have a look at ref implementation, again, it's very similar. They have the constructor here and they're using the private shorthand here. They have get value, which calls track, and we have that as well. And we're eventually going to have set value, which is going to call trigger as well. And we're going to have everything working in a very similar manner. Let's go ahead and get started and implement track. Just to show you where track is located in the code base so you can go ahead and check it out yourself as well, it's going to be inside of effect. And if we scroll down a little bit, we're going to see track is just down here somewhere. Here it is. And it's actually quite small, and we're going to see how this works. Although the code is a very small amount of code, there is quite a bit of complexity here, so we have to go ahead and explain how all of this works. And to do that, we're going to have to go ahead and create some types to handle this as well. So let's go ahead and do that. So the first thing we're going to go ahead and create is going to be these three types up here. Type dependency or type dep. We're going to have type key dep to map, and then we're going to have this const target map. And I'm going to explain these as we go. So the first one is going to be type def, and that one's dep, that's correct. All we need to do is create a new set. I'm going to call any for now. In practice, this is a reactive effect inside of the code base. However, we're just doing something very simple here, so we're going to go with any for now. What this is going to be is an array or a set, which is very similar to an array of all the dependencies of the given value. So in this case, we're going to say the value is going to be this ref implementation here. In our case, we called it foo.ref, and that's going to have a number of effects that are dependent on it. In this case, we're actually going to have one effect that is going to be this effect here. So whenever the value changes, we need to execute this effect. So we need to keep track of the dependencies, in this case, the effect. So what we're going to do is have a set, and that's going to contain a single effect. The difference between a set and an array is a set cannot have any duplicate values. We don't want to duplicate the effects, we just want to have one or each one be unique. So that's why we are using a set here. The next type we're going to have is a key to dep map. And this is going to be a map which is very similar to a regular object in JavaScript. We're going to map any to a dependency. The difference between a key value map or a key value object and a map is you can actually use complex objects for maps here as well. So this is going to look something like this. Actually, let's go ahead and type the last variable and then explain how it all works. So I'm going to create one more called target map. This is actually going to be an object. We're going to use a map instead of a weak map, which they're using over here, just because map gives us a little bit better console logs and it's going to make it easier to understand. We're going to map any to the key to dep map here. What this is going to do is look something like this in the end. We're going to, let's just go and type it out. We're going to have a new target map, which is just going to be a map. And this value up here is going to be the foo.ref. So we're going to map to the foo.ref here and say, okay, this has a number of dependencies. In this case, the dependency is going to be, let's go ahead and delete these comments. They're making it a little bit difficult to type. So we're going to have this foo.ref here, and it's going to have a number of dependencies. In our case, it's actually only going to have one. It's going to be value, and that is going to be a set, and that's going to contain all the effects that need to be executed. What this is going to do then is say whenever this value changes, so foo.ref.value is going to be tracked. Whenever it changes, we're going to execute all of these effects. The reason this is actually a key value map here is we'd like to make this more scalable in the future. For example, you might have something like a reactive type, and that would have multiple keys. Maybe you have A and B in here, and you'd like to track both of these individually. So you could have something like, let's say we had const foo.ref, and this is actually equal to reactive, we'd have foo_ref down here. We might check A might be one effect, let's call it effect 1, and then B might be something like effect 1 and effect 2. So we're going to execute both of the effects when B changes, but when A changes, we're only going to execute 1. And that's why we're setting everything up to be a map. So this is the kind of goal of track, is to build up this sort of dependency tree. So let's go ahead and see how we can do that one. The first thing we need to do now is create a new function called track. So let's just go ahead and define that one. The target was going to be the object we're going to be tracking. In this case, I'm going to call it an object. I could call this a ref implementation because that's all we have in our system. However, in the future, we'd like to change this to actually support all kinds of complex objects. So we're going to make it an object for now. Now, there's a number of things we need to do here. The first thing we need to do is see if the actual dependency is in the target map. The first time we call the effect over here, we're not going to have anything in the target map, so we have to go ahead and set up this dependency relationship. So let's go ahead and do that. The first thing I'm going to do is say let depths map in here, and that's just going to be equal to target map.get, and we're going to grab the target. In this case, it's going to be that ref implementation. If it doesn't exist, what we're going to do is go ahead and assign it to the target map. So we're going to add it to our tracking system. So I'm going to first say depths map is going to be equal to a new set, I believe it's going to be. No, it's not. It's going to be a new map. What am I talking about? And then we're going to go ahead and then assign it to this to target map. So I'm going to say target map.set. We're going to map from the target here as the key, which is going to be our ref implementation. So in this case, it's going to be foobar, and that's going to map to our new map in here. So we're going to map to the depths map like this. So at this point, we have an object that looks something like this. It's going to be foo_ref in here, and that's going to be mapping to a new map, which is going to have a key value pair of some sort of thing inside of here. Let's continue on and see how this is going to look. The next thing we're going to do is see if the dependency exists. In this case, the dependency is going to be value. Of course, it doesn't exist, so we're going to have to add it to the map the first time around. So we're going to say let dep, and let's just call it depths actually. No, dep is probably fine. And that's going to be equal to the depths map, and then we're going to go ahead and grab the dep. In this case, it's going to be value, so depths map.get, passing in a value. In obviously a larger system, this would be dynamic. We'd actually pass in this as an argument to track. However, we only have value in our system, so it's just going to be value for now. Now that we have that, we're going to do exactly the same thing down here and see if it doesn't exist. And if it doesn't exist, we're just going to go ahead and add it. So I'm going to say, let's actually assign it first. Dep is going to be equal to a new set. And then we're going to say depths map.set, and we're going to pass it in here. So it's going to be map value to the new dep. Now that we have that, the final thing we need to do is go ahead and push our effect in. Just to make it clear what's going on, we now have something like this. It's going to be a value in here, and that's going to be a set which contains nothing yet. We need to add the effect in here as well. We haven't actually got the effect anywhere, so I'm going to go ahead and create a new variable called active effect. This is exactly what it's called in the Vue code base as well. I can go ahead and show you that right now. If we just do a search for active effect, it is defined somewhere along the line. Here it is, it's defined down here. So they've called it active effect, reactive effect, or undefined. I'm just going to make it any for now, just to keep things simple. Now that we've defined that, all we're going to do is jump down here and push it in. So I'm going to say dep.set, or dep.add rather, and add the active effect in here. Dep.add is pretty much the same as an array, where we would do array.push. Set doesn't have a push method, it has an add method instead. Now that we've done all of that, we can go ahead and comment this out, and we should hopefully see something similar working. All we need to do is call track inside of get. So let's go ahead and say track and pass in this. Save this one off, head back to our terminal and see what's going on. We have an error here and we haven't got any console log anywhere, so it looks like I've made a mistake. Actually, I haven't, we just haven't console logged anything. Let's go ahead and do a console log on target map and see how this looks now. If we head back here, we can see this is exactly what we expected. We have our target map. It's mapping from the foo_ref here to another map, which is mapping from the dependency, in this case value, to a set. And of course, the active effect is currently undefined because we haven't defined it. So let's go ahead and do that as well. The active effect in this case is going to be the effect we'd like to be calling. It's going to be the only effect we have in our system here. So let's just go ahead and update the effect function down here. I'm going to, before I call the effect here, we're just going to say active effect is equal to callback. And then after we've finished executing this, we're going to reassign this to be undefined. This might seem a little bit unintuitive, so let me show you a diagram just to explain this. So what's going to happen is we're going to call the effect for the first time. It's going to call foo_ref.value, which is going to trigger get, and that's going to trigger this track function. At this point, we've actually set the active effect to be equal to the callback. That's set down here just before we call the callback. So then when we call track, active effect is going to be defined. It's going to add the dependency or the active effect dependency to the dependencies object, And then after this is finished executing, active effect is going to become undefined again. Let's save it off and see if this is working. Heading back to our terminal, we can see it is working. We now have this function down here in the set, and this is going to be the active effect we need to trigger whenever the foo_ref.value changes. So the last thing we need to do now is implement trigger, and that's going to make everything work. Just to show you where trigger is in the code base as well, let's go ahead and find it quickly. Here it is. It's actually fairly complicated. You can see it takes a ton of different arguments in here and does a very similar thing to what you might expect. It gets the dependencies, and then it does a whole bunch of stuff. There's a lot of different checks for different sorts of changes, like clear, see if it's an array, adding things, deleting things. We are going to keep it simple, so we're going to write a much more slimmed back version of this. So let's go ahead and do that. Basically what we need to do, heading back to this first diagram, is whenever we call foo_ref.value equal to bar, it's going to call that setter, and then we're going to call trigger, and that's going to trigger off all the relevant effects. Let's go ahead and implement trigger now. I'm just going to jump up here and implement it near track so it's easy to understand. And this is actually going to be a fair bit more simple than track. We're going to do exactly the same thing, pass in the correct target. We're going to go ahead, grab the dependencies and execute them. So the first thing we're going to do is go ahead and grab those. I'm going to say let depth map again. And that's just going to be equal to target map.get, passing in the target. If this is defined, we're going to go ahead and call them. If it's not, we're just going to go ahead and return early, just for a little bit of defensive programming. So I'm going to return in here. Now we have a dependencies map, and that presumably is going to be what we have over here in our console. All we need to do is iterate over them and then execute all of the effects. So what I'm going to do is say depth map.forEach in here. We're going to iterate over the set using the forEach function. It's going to have a dep, and then for each of these dependencies, in this case it's going to be the value dependency, we're going to execute each of these functions as well. So let's just see what this is. I'm going to just do a console log, and we're actually going to have to call this trigger at some point. So let's go ahead and call this one so we can see the console log. That's going to be down here inside of our ref implementation. We're just going to say trigger in here, passing in this. Let's jump back up there and save it off. And we should see a different console log in here. And so we do. We're seeing a set here which contains a single function. All we need to do is iterate over the dependency. So I can say dependency.forEach, and that's going to be an effect. And we're just going to go ahead and execute this one now. And hopefully this is going to work. It's actually going to give us a very unexpected error. If we scroll up here, it's saying effect is not a function. And if we scroll down here, we can see the first time this was executed, we have a single function in here. However, the second time it's executed, we have a function and undefined. This is a little bit confusing. What's actually happening here is we're executing the first effect. That's going to be this effect over here. And when we say foo_ref.value, we're actually going to call get, which is going to call track, which is going to attempt to push in an undefined active effect into our dependency array. And then we're going to continue iterating over set and try to call the undefined value. This is a little bit confusing, but I'll just show you the solution quickly. All we need to do is have some defensive checks in here. We're going to see if active effect is undefined, and if it is, we're going to return. We don't want to try and track undefined effects. Now, if we save this one off, everything is actually going to pass, and it's all working as you would expect. Let's just go ahead and delete the console logs to make everything a little bit more cleaner. And that should actually give us, there's one more console log, I'm going to remove that one as well. And that's actually going to give us our completed reactivity system for now. Just to show you it working with a more complex example, I'm going to head over here and uncomment this one down here. It's very similar, but we actually have these kind of combo effect in here. We have multiple dependencies we're tracking. We have foo_ref and bar_ref, and this one is passing as well. So this was a lot of information to cover. Although we wrote a very small amount of code, it's around 68 lines long, there's actually quite a bit of complexity here that takes a little while to really digest. I would really encourage you to either go through and implement this yourself, console logging things and figuring out how it works. An alternative would be to come and read the article I'm going to post, and you could just go and work through that one as well. And finally, once you finally understand the mental model, what you can do is come into the actual code base and figure out how everything works in here. Just to show you some of the complexity we didn't cover here, the main one is going to be inside of ref. If we scroll down here, we can see the ref implementation is fairly simple, but it actually contains a lot more complexity, mainly in here. It calls this convert function, and if we look at convert, it's going to see if it's an object, and if it is, it's going to make it reactive. And this has quite a bit of complexity behind it. It's calling this create reactive object function here, which is passing in the target, as well as something called mutable handlers. And if we jump inside of here, we can see it's doing a number of checks, and then it goes ahead and creates something called a proxy. This is a new ES6 construct, and basically it lets you intercept values or changes on your objects. So for example, what we've done over here in our code base is we've implemented our own get and set. It allows you to track those as well as other functions like delete, and that's going to give you complete control over the reactivity of your object. Just to show you how much more complex this actually gets, we have to check out not only the target, but the collection handlers and the base handlers types down here. Collection is the more complex objects like map and set, and base handlers are the more simple things like objects. If we actually go ahead and have a look at base handlers, they're over here in their own file, and they have a bunch of different implementations for get and set. We're going to see track and trigger in here as well. We can see they have get, shallow get, read-only get, shallow read-only get, and a bunch of other ones. If we do check out the get method down here, it has a number of checks, but ultimately it does exactly the same thing as us. It goes ahead and gets the value using reflect.get. It then calls track down here, it's tracking the value, and then ultimately it returns a value. So this is exactly the same as what we're doing. Obviously this is a lot more complex because it's covering a lot of other edge cases and has a number of optimizations, but the ideas here are exactly the same. So definitely go ahead, work through this one and figure out how it all works. In a future video, I'd like to cover the rest of these packages. Some are more complex than others, but I think that's enough for now, so I'll see you in the next video.